Hi, my name's Stephanie, and this year I had the honor of mentoring Kayla, who is a senior here. And this, what we worked on was she's really interested in the intersection of mechanical engineering and computer science. So we were essentially just figuring out ways to build something that's interactive and like could be useful like products for the future and trying to make people's lives better.
So Stephanie is my mentor, and she's a junior studying mechanical engineering with a minor in computer science at MIT. She wants to use her degree to make more interactive and useful objects that can change how people live today. And beyond school, Stephanie enjoys spending time with her friends, families, baking, learning, and reading. So, the basis of my project was for my entire life I've been dancing, and I've always watched dance videos and stuff like that. And I always felt like it was such a waste to have somebody who, it's hard if you're dancing and you have an idea and then you need to have somebody in there to videotape it so that you can have it and upload it and have yourself in the frame the entire time. So my idea essentially was a rotating tripod or base for a camera that moves based on the person's movement. So you don't need a cameraman for a single person video. So we used a servo motor, ultrasonic sensors, and our Arduino for the main component. And the entire time what we were working on understanding how ultrasonic sensors work, their output, which ultrasonic sensor would be the best for human motion detection. And then we also were coding the servo motor and just putting both codes together and creating a running average, because the way that ultrasonic sensors work is that they're not perfect. So sometimes they're a little bit glitchy and some higher numbers will come in or so lower numbers come in. So we're trying to create a running average so that the data can actually be useful and we can actually get coherent numbers in the end. And some pitfalls of the project was that the sensors were not accurate as we actually needed them to be for motion detection from anywhere past about 4 feet. So, and then at the end, the code was also unreliable. It worked sometimes and sometimes it didn't work. It kind of decided based on the run. So I put in my code here. This is just the introduction. It's all of the, yeah, I don't think I'm going to explain the entire thing. And then this is the running average, more of the running average. And then this is the actual component. That's the camera, and you can see the ultrasonic sensors. And then at the top, you can see the circuit. It was a relatively simple circuit. It just connected everything. And then, again, just like Katara, I'd like to think everybody working with Stephanie was really a new and exciting experience. I've never gotten to work more on my coding as much as I hoped, so this was a perfect experience to do something like that and make a project over a long period of time. And now I can take this project and move from this point in the future and use the skills that I've learned.